What's going on, guys? In today's video, I'm gonna be teaching you guys machine learning, and we're gonna go over the most basic model, which is linear regression. So machine learning is a method of data analysis, and it automates analytical model building, and it's a branch of artificial intelligence. There's more to artificial intelligence, like NLP, which is natural language processing. I'm gonna make more videos on natural language processing in the future, which that basically it can make a bot or the computer understand human language. And then there's machine learning, and there's a lot of other fields in AI. So for this series, I'm gonna go over machine learning and the models and how to analyze data. So there's two types of models in machine learning. There's two types of ways that the computer can learn data, which is classification and regression. So what is classification? What's the difference between classification and regression? So classification is fundamentally predicting a label for data points, or just data in general, and regression is about predicting a quantity, or predicting a number in a graph, in an XY graph. So the classification is the problem of predicting a discrete class label or output, for an example, and regression is the problem of predicting a continuous quantity output for data. So there's different types of models for each of these learning types. So for classification, there's k-nearest neighbors, support vector machines, k-means clustering, and this is just different algorithms to actually analyze data. And then there's linear regression, logistic regression, and all of these different types of regressions to analyze data. So we're gonna go over linear regression today. So before we get into the code, let me just draw a graph for you guys so you guys could better understand what linear regression is. So over here we have some data points. Let's say that all of these data points is the number of crashes due to drinking and driving. So let's say Y is the accidents and X is the year. So let's just make some points right here. So right here, we want to basically do linear regression and have a really good line of best fit for these data points. So right here, we have y equals mx plus b, which is a slope, a constant slope. And we basically just made a line of best fit, which could predict future number of accidents. So with this line of best fit, let's say the year 2021. Let's say that we predict that this point is the predicted amount of future accidents, and basically machine learning tries to make it as accurate as possible. The more the data, the more the accurate the model can be in predicting these points. So that's basically what linear regression is. So let me erase this. So what if we get a real big scatter of points? Like what if let me just erase this. So let's say if we have three axes, we got x, y, and z. So we have x, y, we have z. So what if you get points that are scattered all around, all around the graph. So let's just, draw points all around the graph. So now let's say if you want to just group these points, right? Now this, when we group points like this is called classification right here. I accidentally left out a few points. Let's just pretend that it was in a circle. So this is what we call classification, or let me just highlight this, classification. So what is classification? It basically is predicting a label for all of these data points. So the label can be, this can be labeled X, this can be labeled Y or whatnot, this can be labeled B, and we're basically classifying data. So now we're gonna move on to learning linear regression. So before we move on to the code, you guys should basically install these packages. So basically what you want to do is open command prompt, and you want to do pip install and then replace the underline portion with TensorFlow, and then do the same pip install for pickle, keras, numpy, and pandas, and sklearn, because that's what we will be using in this tutorial series. There'll be more packages in the future, but if there's a package that you haven't installed, I'll say it in the beginning of the tutorial. So just for linear regression, we will need these packages, all of these packages. So make sure that you got all of these packages right here. So yep. Okay guys, so now we're gonna load in our data sets. So right here we have a new Python file which we're gonna have to create, and over here we have a CSV file which basically holds all of the data. So what it is, it has a student's teacher, the course they're taking, their grades, and whether they're gonna pass or not. We're gonna basically just predict whether they're gonna pass a grade or not, and etc. There's gonna be more things to analyze in this data set. So this file will be linked in the description. The download will be linked to the description for this file, and you basically just wanna put it in the same folder as your Python program. And yeah, you just want to make sure that your TensorFlow and all of your packages, such as pickle, keras, numpy, pandas, and sklearn, we want to make sure that it's all in the right version and there's no errors basically, and your code's gonna run properly and smoothly with all these packages, and obviously TensorFlow. So yeah, let's move on and let's start basically coding. So first we want to make sure that we import all of our packages. So let me just import all of our packages right here. So let's go ahead and do that. So we're gonna do so you can just code along with me. You can pause the video if you need more time. And also I'm gonna get a new keyboard so you won't have to hear this membrane keyboard in the background. Okay, why is that? That's my bad. Import sklearn, and then from sklearn import the linear model. Not the linear model, and then from sklearn we wanna get the utils and import shuffle. So this should be all of our import statements, and now we want to basically read our CSV file. So we're going to do data equals pd dot read that's basically going to read our CSV file, and in the parameters we want our student dash mat. So we have student dash mat dot csv comma, whoops, that was sep equals, so we're just gonna separate this. So we're gonna basically, so since our data is separated by semicolons, we need to do sep equals this, so we know that it's being separated by these semicolons right here. So let's move on to the next stuff. So now we want to just print our data head, and add some more parentheses. So reprint this out. Okay, now let's do data equals data, and then we can have some brackets in there. So we're gonna have, so looking at the CSV file, we basically want to assign all of these different data, so school, sex, their age, their address, their family size. We want to just take this data and assign it to variables. So let's go ahead and assign that. So we got the G1. G2. G3. Time. And absences. So that should be good, and now we basically assigned some variables to these data points, and now we want to separate our data. So now that we trimmed our data set down, we need to separate it into 4 arrays. So hopefully I did cover arrays in the last video on the intro to Python, so hopefully you understand it. If you didn't, you can review your arrays by going into the last video in this playlist, which was the basics of Python. So let's go ahead and label our attributes and whatnot. So we're gonna do predict equals 3, and we're gonna do x, and we're gonna have a y. So we're gonna do x. Let's go ahead and make this not capital because it's gonna be way easier. np dot array, and then we're gonna have the array do data dot drop, and in our parentheses we're gonna have brackets, and then predict, and then comma 1, start at 1, and we can have y equals the same thing, but we're not gonna drop it, and we're not gonna start at 1. So we just do this. It's gonna be the same thing, but without this, without dropping it. Okay, so right here we have our features, and right here we have our labels. And now we just want to test and train all of our data sets, and we will use our 90%. We'll use like 90% of our data to train, and the other 10% to test. And yeah, we're not gonna really test our model. We do not test our model on the data that's already been seen. That's already seen, because that's just not that this doesn't make sense, to test data that's already seen. So let's go ahead and train our data. So x underscore train sklearn dot model underscore selection. Wait, let me just make this, capital X, so I just don't forget. So it should be underscore. So right here, we've implemented our linear regression algorithm, which is pretty cool. So let's move on to, I think we have, successfully implemented our linear regression model right here. So if you've been following along, congratulations, because this is your first model that you've made. And now we're just going to move on to really implementing our algorithm and predicting on specific students in our data. And let's just move on. So we'll start by really defining defining the model that we'll be using. So we'll be using linear regression, obviously. So we're going to do linear equals linear underscore model dot linear regression, and then we'll do linear dot fit x underscore train, and then y underscore train, and we'll do count equals linear dot score, and then we're gonna do x underscore test and y underscore test. Okay, so right here, we are basically, it's actually ACC, which stands for, not count, but ACC stands for accuracy. Now we just want to print the accuracy, which will be in decimal value. And so for this specific data, I think a score of above 80% is fairly good. So 80% accurate should be pretty good for our data set right here. And if you want to see constants using the used to generate the line, we can always type print with linear.coef, which is COEF underscore, and this basically prints out the coefficients. And you can also do linear.intercept underscore, which prints out the intercept. So I'm gonna just print that out right here, and we will get the slope value and intercept of our data set. So now let's move on to the predicting on specific student types. So okay, wait, so we got data frame object not callable on line 16. So let me see that. 16, so it says it's not callable, hashtag data frame is not callable. Okay, let me quickly fix that problem. So let me just fix this right here. Okay, let's just move on to our steps here. So we have let me just look at my notes to complete. Yeah, okay, so we have to predict specific students, so we're gonna do predictions equals linear dot predict x underscore test. Yeah, basically what that will do is it will get a list of all predictions, and then we're gonna make a for loop. So for x in range so it's basically going to take the length of prediction as an array, and it's going to run a for loop to check if, and it's going to basically just do a run for loop to just print the predictions. So let's go ahead and print out all of these predictions. So okay, we're getting some errors right here. However, this should just fix it. This be a nice little fix. There we go. And we should get some output right here. So let's I think let's move on to the next part, which is really saving our model. To save our model that we write to a new file using pickle.dump. So what pickle is it's a way to actually plot your data or save it to save your model. So let's go ahead and do that. So I'm gonna do, oh yeah, and we're gonna have to import some new libraries here. So I'm gonna delete this. I'm gonna import some new libraries. So I imported matplotlib.pyplot, which basically plots data, and we imported a style for it. It's just personal preference, and we also imported pickle. So let's go ahead and do this. Okay, so I'm getting a variable error right here. So let me just make sure that I'm doing this right. So let me just make sure I'm doing this right. There we go. Whoops, I don't know what's happening. That should work. So now we can use linear to predict grades like before. So we're just gonna we're gonna basically train multiple models. Let's go ahead and do hashtag train model multiple times for best score. So we're gonna do best equals 0 for underscore in range of 20, and then this, and we're gonna do x underscore train, y underscore train. Oh wait, x underscore test. So we're gonna just train another model again, and we're gonna do x, y, test equals 0.1. And now we're gonna do linear equals, we're gonna choose a linear model, so linear. Do that. And we're gonna do linear, we're gonna fit the points, so linear dot fit into the graphs. And we're gonna put underscore train wait for the score you want to test it. So right here, if the current model has a better score than the one we've already trained, then we're gonna save it. So we're gonna make an if statement basically. So if account equals best is greater than best, my bad, then we're gonna do best equals account, and then with open. So we're gonna use pickle.dump now. So that's what we've done. So this is pretty cool. Now we use pickle.dump right here. Now we're gonna plot our data. So let's go ahead and just draw. So we're basically just going to do plot equals failures. Just follow along and explain everything. So we're gonna do data, parameters plot, and then data. G, we're gonna do G3 I think. I'm gonna use G3, which is age, I think it is. Age. According to age, and then we're gonna do plt.x label, so we're gonna use our labels now. And plot that. We'll do plt.y label. We're gonna make it final grade. So we're gonna predict our final grades, and we're gonna do plt.show, which is gonna show our data. Okay guys, so now we're basically done with making our first linear regression model. We have our code right here. All this code is going to be in the description in my GitHub, so be sure to look at that. And now we're going to run the code, and we're going to get a really cool, we're going to get some accuracy points, and we're also going to get a graph, which basically plots our data right here. So we have of our final grades, and we have the failures. So right here, as you can see, it basically predicted and use regression for all these data points, which is really cool. So we have the final grids, predict the final grids and the failures. And right here we have the accuracy. So we got some 76. We got, okay, let me go to the latest model. Wow, so we got 89, which is really good. 91. Wow. You know, we got some 76s for some of our accuracies, which is not bad. And right here we have most of our data points for a selection of students. So I think the more you run it, the more it updates the model, and you know, the better it is, because you're basically training your data set, you're training your machine learning model to be more accurate. So right here we got a 92%. Wow, really high, with some really high accuracy. So there we go, guys. We trained our first model with linear regression, and we also plotted some of our points for predicting the final grade for these students. So that's gonna end it for today's video. We can do really cool things with linear regression. We can even predict the stock market with linear regression. Obviously, even humans, or even AIs or humans, cannot really predict the stock market, but for learning purposes, I can probably make a tutorial on how to predict the stock market with linear regression, and we can also use some other models. So that's gonna end it for today's video, guys. Hope you guys really learned something new, and how powerful machine learning is, and how powerful it can be if you feed more and more data to your models. And yeah, that's gonna end it for today's video, guys. Hope you guys enjoyed it. Please like and subscribe to view more videos like this coming up. So I'm gonna make way more machine learning videos, and I'm also gonna be sure to check out some of our SAT videos, our chemistry videos, and our math videos. We make all types of videos, and yeah, if you wanna brush up your Java skills, you can also check out our programming videos in our playlists. So that's gonna end it, and yeah, enjoy your day. See you.